Hey guys, in this video, we're going to look at the 2022 AP Calculus BC exam, free response question number one. This is also the number one question for the 2022 AP Calculus AB exam. The question reads, from 5 a.m. to 10 a.m., the rate at which vehicles arrive at a certain toll plaza is given by A of t is equal to 450 times the square root of sine of 0.62t, where t is the number of hours after 5 a.m. and A of t is measured in vehicles per hour. Traffic is flowing smoothly at 5 a.m. with no vehicles waiting in line. Now, part A, write but do not evaluate an integral expression that gives a total number of vehicles that arrive at the toll plaza from 6 a.m. T equals 1 to 10 a.m. T equals 5. We're given A of t, which is the rate at which the vehicles arrive. So in order to get the total number of vehicles within a specific range of time, all we need to do is integrate A of t using the proper boundaries. Now the problem simply asks you to write but not evaluate the integral expression. So all we need to do is show integral of A of t dt from 1 to 5. And it's always a good habit to give complete answers. So our answer is the total number of vehicles that arrive at the toll plaza from 6 a.m. to 10 a.m. is expressed by the integral A of t from 1 to 5. Now moving on to part B, it's asking us to find the average value of the rate in vehicles per hour at which the vehicles arrive at the toll plaza from 6 a.m. to 10 a.m. Now the average value is given by the sum for the integral over the interval of time. Now in our problem specifically, it will be the total number of vehicles divided by delta t. Now we found the total sum from the integral we found in part A. So we'll represent this as 1 over 5 minus 1 times the integral of A of t from 1 to 5. Now we're going to use our graphing calculator to evaluate this expression. So first I'm going to go to y and plug in A of t in y1. I think we're going to use this function several times in this problem, so I want to have it handy. Make sure that you check that you're in the radians before you make any computations. And now I'm going to do 1 over 4 times, go to math, FNINT of function y1, take my variable from 1 to 5. And when I press enter, it will tell me that the average value of the rate is 375.537. And again, I want to give my answers in complete answers. So I will say the average rate at which vehicles arrive at the toll plaza from 6 a.m. to 10 a.m. is 375.537 vehicles per hour. Okay, let's move on to part C. Part C is asking, is the rate at which the vehicles arrive at the toll plaza at 6 a.m. when t is equal to 1 increasing or decreasing? Give a reason for your answer. When you're looking for whether a function is increasing or decreasing, you need to find its derivative to see if it's positive or negative. So the problem asks whether the rate at which the vehicles arrive at the toll plaza, which is your A of t, is increasing or decreasing at t equals 1. So what we're looking for is A prime of 1. This expression is easy to evaluate using your calculator. Remember from part B that we have the function A of t stored in y1. So this time we're going to go back to math, and instead of FNINT, we're going to do n derivative of y1, define your variable, and evaluate at 1. And it's 148.9. So A prime of 1 is 148.9. meaning a prime of 1 is greater than 0. This means the rate at which vehicles arrive at the toll plaza at 6 a.m. is increasing. Now, the last part of the problem says a line forms whenever A of t is greater than or equal to 400. The number of vehicles in line at time t for A is less than or equal to t less than or equal to 4 is given by n of t equals the integral from a to t of a of x minus 400 dx, where a is a time when a line first begins to form, and to the nearest whole number, find the greatest number of vehicles in line at toll plaza in the time interval a is less than or equal to t less than or equal to 4. Justify your answer. Now the last question introduces a new function n of t and asks us to find the greatest number of vehicles in line at toll plaza, and in other words, the maximum value of n of t for t between a and 4. Remember that a function's extreme points must occur at the critical points or the endpoints. So let's first find out what this value a is. Again, a is a time when the line first begins to form, which is when a of t is equal to 400 for the very first time. So let's go ahead and take out our calculator. Again, the function a of t is saved in y1. I'm going to store the value 400 in y2 and see when these two will intersect. When you graph these two functions, we'll use the calculate to find the intersection between these two graphs. And it tells me that the first time when they intersect is when t is equal to 1.469. So a is 1.469. Now that we have the endpoints, we're going to find the critical points of n of t, which is when its derivative is equal to 0. So using the function n of t given, we see that n prime of t is equal to a of t minus 400, which is equal to 0. Now, if you don't understand how we arrived at this equation, the math is shown on the right. Feel free to pause the video as long as you need to look over the step-by-step explanation. Well, this equation is exactly the same equation we used to find the value a earlier. So going back to our calculator, let's see when these two functions intersect again. So I'm going to calculate the intersection point between function y1, function y2 at this point. And that is when t is equal to 3.598. I'm going to call this point B. And based on our graph, there were no other extreme points. So let's evaluate n of t at these three potential extremes. I've previously stored the values of a and b in my calculator as shown. Now, when t is equal to a, we know that n will be equal to 0 because we're integrating from a to a. Now, when t is equal to b, you take the integral of y of t, y of 1, minus 400, define your variable, from a to b, and get 71.236. And you do the same thing, but from a to 4. And you get 62.338. We see that the n of t is the greatest when t is equal to b, or 3.598. So the greatest number of vehicles in line at the toll plaza is 71. And all right, so this was 2022 AP Calculus AB and BC free response question number 1. Hope you found this video to be helpful, and see you in the next video.